And machine learning is the best application by now, by today, of artificial intelligence, okay? The other thing that I want to be clear about is that, as I told you, the title of the session is Data Science for Business. So I want to be sure that we don't mistake data science with big data, because these are two very different concepts. Because when we talk about data science, we are talking about a process that uses big data technologies, but it is very different from big data, because big data technologies are something that was born from the need of analyzing huge amounts of data, okay? So these are two very different concepts. That said, what is the goal of data science when we're talking about data science for business? It's improving decision-making as a direct interest to the business, okay? And how can we do that? What do you need? Three fundamental things. First, data. Data is a business asset, is your business asset. Without it, you cannot do data science in general, or apply machine learning to something that you have in your solution, okay? So since it's a business asset, you also need to consider how much you want to spend on it. So how much do you want to invest in the data that you have? The second thing that you need is, of course, knowledge of the context. You want to resolve a problem or to improve a process, and what you need to do is having knowledge of this process or this problem. Otherwise, the data that you will have for you will not make sense, okay? And the third thing, that is the last one, but not for importance, is a data scientist. So when we talk about data science process, you need three individuals: a business stakeholder, a software engineer, and a data scientist. Can a software engineer be also a data scientist? Yes, of course. But you need to consider in this case that you need time to train them, because being a software engineer and a data science are two very different things, okay? So how can we define a process that you can repeat and that is objective to analyze the data that you already have? We're going to use a framework that is called the team data science process. And it takes the idea from, I don't know if you're familiar with it, but with the CRISP model, which is a framework for data mining processes, okay? And it has four main components: the business understanding, the data understanding and preparation, the modeling, and the deployment, okay? And each of these four steps actually has a set of sub-steps that you need to take care during the process. Now we're going to go into details. So let's start for the first one, business understanding. What does it mean? It means that you need to define the project, the idea, the goal, the question that you want to answer for your data science process, okay? And this needs to be sharp, specific, and unambiguous, okay? So questions such as, what can my data tell me about my business? It's not unambiguous, it's not specific, it's generic, and I'm not really sure that data science can help you with that. Maybe some data analysis can, but it's different from doing a data science process, okay? Another question that doesn't make sense is, how can I increase my profit? And I can assure you that this is a question that I get a lot. So how can I increase my profit? I don't know. We can take a look at your data. We can think about it. But it's not a question that you can resolve with data science process, okay? Specific and unambiguous questions are such as, which kind of car my fleet is going to fail first, okay? Or another one can be, how many licenses I will sell of X during this quarter. These are very specific and unambiguous questions, and you can solve them with a process. How can you specify and be sure that your question is unambiguous? First of all, keep in mind that this is an iterative process. So you're going to try with the first question, you're going to see that this is not unambiguous, and you're going to try again and again. And sometimes you're going to come up with questions or with a problem that actually you can solve just dividing the problem in sub-problems. And this is totally fine, okay? It's in the process, it's something that you need to take in consideration. But it's vital, as I said to you before, that you understand the problem that you are going to solve. So if you don't have the context, it will be very difficult for you to solve it. The other thing is that the more specific the question is, the easier it will be for you to follow this framework, okay? So At the end of this step, you should be able to have a defined and unambiguous question that will specify a target. And this target will be a quantity or a category that you want to predict or assign. Okay? It's very simple. The next step is data preparation. Of course, as I told you before, data is an asset. And usually, you already will have data in your business. And I'm sure that your data set will be noisy, missing some values, or will have something other things weird inside the data, because maybe they are logs or other stuff. So what you can do to make your data valuable and actually ready to be used in a data science process. First of all, you need to do data summarization and then data visualization. What does it mean? Data summarization mainly is statistics on the data that you have. Visualizing the data will help you to see if you missed something or if there are some values, there are discrepancies between what you were expecting. And it's something that will help you understand better the data set that you have in your hands. We have a notebook, a Jupyter notebook, which is just for who is not familiar with Jupyter notebook, a set of steps that you can use to do data summarization and visualization. That it's called IDEA, okay? Interactive Data Explanatory Analysis and Reporting. It's a long name, but can help you doing all the first step if you're not familiar with it. Can help you doing all the steps that you need to do some summarization and reporting. At the end of this step, what you should have is an understanding of the data that you have, and the data should be ready to be used to prepare the machine learning model, okay? So you need to have normalized the data, edited the data, do whatever you needed to do to make the data ready to be used. The other thing that you need, and this is usually comes with the data preparation, is the data understanding. Because I'm pretty sure that everybody has a data set, and you started collecting all the information that you have without a clear scope. So maybe they were log files, maybe they were just information that you were collecting to be sure that everything was working. So probably when you were collecting, you had no business reason at all. And this is something that you need to take care of. Because if the data that you have are not fitting the question that you were asking at the beginning, it's going to be hard to find a solution to your problem, right? So, as I said before, data is your business asset, and you need to invest in it. And in the case that your data set is not ready, actually, to be used to solve the question, you need to take in consideration some investment. And investment can be monetary, so you need to purchase a data set from someone that already has it. Can be about availability, because maybe there is a free data set that actually can answer my question, but I need to be able to reach it and use it, okay? Or about time. So I don't have the data set. I cannot spend money on purchasing a new data set. I need to collect the data in some ways. Now I have a clear business intention, and now I know what I want to collect in order to answer my question, okay? So at the end of this step, you should be able to know which data do you have, what data do you need, and how much will it cost you in case you need to improve the data set that you already have in your hands. Before we go to the next steps, I need to specify two other concepts that are pretty important. In machine learning, when we talk about model, you can have a supervised or unsupervised models. Supervised models means that you have a data set, and inside this data set, you already have the answer, the target that you want to predict, okay? So let's take an example. For example, I want to be able to categorize the fruit. I want to be able to say this is an apple and this is an orange, okay? The idea is that if I'm using a supervised learning, I already know what makes an apple and an orange an orange. So I will have a set of features such as, I don't know, the number of the leaves, the skin, the color, the shape of the fruit, and then my last column of the data set will be the category. So if it's an orange or if it's an apple, okay? And the idea is that in this case, I already know. And I teach the algorithm what he has to do to recognize when apple is an apple and an orange is an orange. When we talk about unsupervised learning, we are talking about an algorithm that actually looks for regularities or patterns inside your data set. This means that I take just apples and oranges, I give it to the algorithm, and I just wait to see what it finds out. So it will probably separate the two, but without telling me, OK, you know, group 1 is apples and group 2 is oranges, because it doesn't know what they are. It's going to just tell me, you know, group 1 has something in common, such as, I don't know, the skin is smooth. And the other one has the skin that is different from smooth. So probably they are two different things. But it doesn't know what they are. It's you that have to take a look at the data set and tell the machine or distinguish which are the two groups that he found, OK? Another example can be that the two groups are for the color. I don't know, he finds out that all these have the similar color. All these other groups have a similar color, but it doesn't know what they are. So this is important because when we go to the next step, after the business understanding, after the data understanding and preparation, we have the modeling. And the modeling is composed in two main steps. The first one is called feature engineering, and the second one is called model training. Feature engineering means that you're going to take a look at your data set and you're going to take a look at which are the variables inside the data set that are actually important for you in order to answer your question, OK? So, for example, in the case that I said before, oranges and apples, probably you're going to need, I don't know, the skin color or the skin, if it's bumpy or not, and all this stuff. And what it requires, this step, usually, is domain expertise, because if you don't know the domain, you will not know which are the features that actually are important for you, and insights from the data that you looked before, OK? When we talk about model training, we are talking about defining a relationship between the feature that you have and the output that you want, OK? It's a mathematical function, basically. You will give it some input, and you will expect some output. But it's a parameterized function in this case. When you're going to create the model, you're going to divide your data set in two. One is going to be the training set. The other one is going to be the testing set. The training set will teach your algorithm, your machine, what he has to do and how he has to predict your target variable. And the testing will check how good the model is on the data, OK? So at the end of this step, you usually should be able to have a model that is tuned on the parameter that you set up, OK? And that fits very well, or at least good, the data that you give it, the new data that you give him. The last step, almost, the evaluation step, usually is the step that you need to take in consideration after you create the model, because we are talking about business, right? So I need to be sure that my model actually is rigorous, valid, and I can replicate it anytime inside my new data, the one that they're going to come. I need to evaluate if actually answer my business goal, and I need to discuss it with the stakeholders, of course, because if it's not answering the business question, so if you're not going to have a return of the investment that you did by now, you need to take a step back. And I want to stress a lot that this is an iterative process. So it is totally fine to go back to the step 1 or to the step 2, or in which step of the process you think it may be useful to go back to start again, OK? So at the end of the evaluation process, what you should be able to have is an idea of a model that actually doesn't, by chance, calculate or predict your target goal, but actually is able to extract patterns and true regularities from the data that you give him, OK? The last step is you should deploy your data science process and not the model. And this is fundamental because, and this is where the software engineer needs to help the data scientist, OK? Because when you deploy just the model, you will not be able to follow the fastest, the velocity of the word. So if you're collecting the data and the way you collect data changes, in some ways, you need to be able to change the process without changing everything and starting again the process, OK? So what you're going to do is basically try to deploy every step so that if there are changes, you can just change one part of your project and not redo everything by the beginning. And last thing is, a business has too many models, too many processes that can be improved by machine learning. And so it can be very difficult to have deployed thousands and thousands of models and keep them up to date to the business. So in the end, you should be able to have your process completed and deployed and see the return of the investment that you did. Thank you.
Thank you, Guenda. That was really great. So now we see that we haven't had time to really post too many questions, so please use this time right now to post whatever questions that you might have on Slido. Use the hashtag AIC18. Now, Guenda, would you like to answer?
Python or R?
Yeah.
OK, it depends, actually. I saw, from my experience, that actually Python is mostly used by developers that try to do data science and are more in the educational sector, so more for researcher or university or research center in general. So it depends. Actually, they are pretty good, both of them. They are used, both of them. In my opinion, Python, it's easier to learn. So if you need to choose one, probably Python, it's easier. R does better graphs. So it depends on who is going to choose the language, actually. So.
Perfect. OK, next question. Do you have some real business example how DS helped?
Real business examples. Yes, well, it depends. Like, for example, bots are a way in which you can implement and make a business process easier. For example, call center, maybe, or when someone, or a help desk. It's easier if you have a bot that actually help you with intelligence, understanding what the person is saying, help you dividing the problems in something that needs a human person that helps the customer, or in something that actually they can find, I don't know, a guide or an FAQ somewhere in the website, and that actually can help them solving the problem. So this is an example, pretty common.
Perfect. OK, so actually, I think because business example cases, so OK, that question disappeared. OK, now because I wanted that one, the one with the 3, how can you sell a business case to stakeholder without clear ROI? How can you define ROI for AI on an untapped data set?
OK, that's a tough one. I don't know, it's difficult to convince stakeholder, but what you need to talk about with the stakeholder is also how they can improve the process, something that usually is an automatic process, or something, as Chris said this morning, a boring job, something that is repetitive. So usually the advantage is this one, and you can scale it up in different business application. For an eye on a top data set, I don't know. The second one, I don't know how to answer.
OK. Cool. Let's go to the last question, which is what are the core competences or skills of a data scientist in your opinion?
OK, so statistics for sure, because you need to have a base of statistics, otherwise it's going to be very difficult for you to analyze the data set. Some programming skill also, because if you need to use R or Python, you need to program in some ways, for sure. And probability too, also. It's another thing that it's really important, because a lot of algorithms that you use are based on probability concepts, so you need to understand that part too. And of course, if you have also mathematical skills, it's going to help you understanding in deep dive the algorithm that you are using, actually.
Cool. OK, so maybe I think we have time for one more question. And the highest ranking one right now is, how does TDSP improve on CRISP-DM?
There are two different concepts, actually, because CRISP is about data mining, And the team data science process is about the data science process, so not only on data mining processes. So they are really similar because, of course, some data mining is needed when you do a data science process, but they are two different. They have two different goals in that sense.
Perfect. Okay, so thank you very much, and please give a round of applause again. We will resume here at 5:30. Thank you.